So let's look at a derivative real quick with logarithms or exponential functions. Here's a combination of the two. Let's say that I had y equals the natural log of e to the negative 3x plus 4. So to find this derivative, I'm going to need to know my rules for taking the derivative of natural logarithms. And I'm also going to have to know how to find the derivative of an exponential function, because my u here is e to the negative 3x plus 4. So my du then would be negative 3 e to the negative 3x, and then the derivative of the plus 4 is just 0. Now, I did all that because I need the u and the du when I take the derivative. Remember, the du doesn't have to be present to take a derivative. We multiply by a du. But I have to follow my rules for the derivative of natural logarithms here. Remember, your formula for the derivative of a natural logarithm is 1 over u du. So it's going to be 1 over, here's my u, so 1 over e to the negative 3x plus 4 times my du. So that's negative 3 e to the negative 3x. So that's going to be negative 3 e to the negative 3x over e to the negative 3x plus 4. And you cannot cancel out because of the plus 4. If you had a product, you could cancel out, but there are no products, so you need to leave your answer like that. So make sure with natural logarithms that when you take the derivative that you use the appropriate formula, 1 over u du. Alright, now what about integrals involving exponential functions? See if I can find us one of those. So let's say I had the integral of e to the 1 over x squared over x cubed dx. This one looks very strange, but if you think about this as e to the u, and you let your u equal 1 over x squared, or x to the negative 2 power, then what is your du? Negative 2x to the negative 3, or negative 2 over x cubed, right? And so you see this here in the denominator? There it is right there in the denominator. So your du is actually present here. The variable part is. The only thing we have to do is adjust for the constant. So when I rewrite this integral, I have to bring out a negative 1/2. And then I have e to the u du, right? Because the du contains the x to the 3rd power in the denominator, just like in your original integrand. And the integral of e to the u du is e to the u plus c. So it's negative 1/2 e to the, what's your u? That 1 over x squared plus c. So the key to this integral is picking the u, finding the du, and then noticing that the du is present in the integrand. Once you see that the du is present in the integrand, then look how neat it is when you rewrite it. It looks a lot different than before. But it's all about getting good at rewriting these things to make them simpler so that you can integrate them. Let's look at this one. The integral of e to the negative x over 1 plus e to the negative x. Okay, so we got to think about what are our tools for integrating fractions like this. Well, maybe it's a fraction just like the previous problem. Could I possibly choose a u so that when I find my du that I would have my entire denominator there? No. Like if I choose my u as negative x, then my du is just negative 1. Or if I choose my u as e to the negative x, then my du is negative e to the negative x. And I don't just have that present in the denominator. And so what you want to do when you see fractions, if you can't choose a u and have a du present, is you want to go to the train of thought. You want to ask yourself, is this a natural log integral? That's the first thing that you want to ask yourself after you've tried to choose u's and du's and nothing's worked. If it's a fraction, is this a natural log integral? Alright, and so the way you can tell if this is a natural log integral, you let your entire denominator be your u and find your du. And so if I let my denominator be my u and I find my du, the derivative of 1 is 0. The derivative of e to the negative x is negative e to the negative x. And so you can see, if I let my denominator be my u, this du, other than the negative sign, is present in the numerator. And so I adjust for that negative by putting a negative out front. And how do I rewrite this thing now? This is what? The integral of 1 over, I just let my entire denominator be my u. So 1 over u du. And so you can see this integral that looked very complicated at first, now I've rewritten this, and this is the formula for the integral that would give you natural log. The integral of 1 over u du is natural log of u plus c. So this is negative natural log absolute value of u plus c, or negative natural log absolute value of 1 plus e to the negative x plus c. So when you see fractions, that's what you need to think. If you can't just choose a u and get a du, is this a natural log integral? Alright, let's look at this integral. The integral of e to the x times the square root of 1 minus e to the x dx. Now I don't see a fraction, so it's not going to be a natural log integral. My best bet is to try to find a u so that my du would be present. So what if I chose my u to be 1 minus e to the x? Then my du would be what? Just negative e to the x. And look, this e to the x is present in front of my radical. So how would this thing rewrite now? Of course, I got to bring a negative out. Integral. I let my u be everything under the radical. So it's u to the 1/2, right? Not just u, but u to the 1/2, or the square root of u, du. A common mistake here is for students, just when they rewrite it, to just write integral of u. But I let my u equal everything under the radical. So when I rewrite this, I have to make sure that I make that u to the 1/2. So now power rule, so that's going to equal negative, add 1, divide, so divide by 3/2, so it's going to be 2/3 u to the 3/2 plus c, or negative 2/3 times 1 minus e to the x to the 3/2 plus c. Alright, so that's what we'll pick up on Friday.